is yours.
Okay. Well, I think I have about 30 minutes and I will give two presentations. The first will be about the Flemish waterways itself, and a second presentation will deal with the Sigma project. So I'll try to speed through it. The Flemish Waterways is an autonomous Flemish agency which is situated in the policy domain of mobility and public works. I think you have seen this screen before when Patrick Peters gave his explanation. You can see that we have a ministry, a Flemish Ministry of Mobility and Public Works, in which the department is situated where the laboratory of hydraulics is situated, but the Flemish Waterways is not part of the ministry itself. It's an agency. This is our operating area. You see that we have three areas. The west area in yellow is mainly canalized rivers and canals. The central green area, we have mainly tidal rivers, the river Scheldt and its tributaries, and a few canals. And in the east area, we have mainly canals, for instance, the Albert Canal and a small piece of the River Meuse, close to the Dutch border in the extreme east of Flanders. Of course, we are part of the EU corridors. Our main tasks is to maintain and develop the waterway network and its assets. We stimulate transport over water to improve the mobility in Flanders. Of course, we apply our best water management, and we facilitate and stimulate other functions. Here you can see some key figures. We have 1,300 employees. We have a budget of about 500 million euros a year. 1,076 kilometers of navigable waterways, 800 bridges, 131 locks, 195 kilometers of quay walls, 1 million TEU containers transportation per year, 72 million tons of freight per year, and 2,046 kilometers of tow paths along the rivers and canals. The growth in the traffic of containers is quite spectacular. In 20 years' time, we have a tenfold in amount of containers transported, and that is due, of course, to the development of the container terminal in the port of Antwerp-Bruges, and it will still increase since Antwerp will increase its capacity the next years. A couple of challenges. The mobility will increase of 25%, at least that's what expected in by 2040. Second challenge is climate change, an increase of risk of flooding and drought. And we take on these challenges by investing in sufficient maintenance, developing the network, like for instance, the Seine-Schelde and the Albert Canal. And we invest also in infrastructure to deal with floods and droughts. This shows the Seine-Schelde project, in which we try to connect the Benelux countries with Le Havre, Rouen, and Paris, and which needs investments also in France, of course, because there's a new canal to be created. The upgrading of the Albert Canal. The Albert Canal is a canal that relays Antwerp with Liège. It also makes the junction between the Meuse and the Schelde basin. And here we are increasing the height of all the bridges to 9.1 meter. so as to make the transport possible with 4 layers of containers. And then there's the Sigma plan, but I will give another presentation, so I will not state further on this here. We are also installing pumping station and water power plants at the locks. It's because of adaptation to climate change. The good thing is that it can work in both directions. So in moments of droughts, we can pump the water back, and in moments of too much water, we can use it as a power plant. We also invest in entrepreneurs, of course, for instance, constructing K-walls and multimodal business parks. We invest in innovation and automation. We have our smart shipping program. We facilitate innovative concepts of transport and loading and unloading. And we also invest in strengthening the multifunctionality of our rivers and canals. Our aim is to be a reliable partner for smart, versatile, and prosperous inland waterway network. So that was the first presentation about the Flemish waterways. I don't know if there are any questions, or should I continue with the second presentation? I'm trying to. I hope that yeah, this is better. I hope you can see my screen. Okay.
Yes, we can see it.
The next presentation, as I said, is about the Sigma plan. Maybe, probably some of you already had a presentation on it, but I think it's still useful to get a little rehearsal. The Scheldt River and its tributaries in Flanders form a tidal river system. The overall length is more than 250 kilometers, and we have a tidal range up to 5.5 meters in normal daily circumstances. The Sigma plan covers, the Sigma plan covers a large part of the Scheldt River catchment, and you can see where it is situated in Flanders. Heavy storm and wind surge can cause very high water levels in Antwerp and upstream along the river Scheldt. In the past, this led to severe and uncontrolled floodings, as in 1953 and in 1976. Here you can see the village of Ruisbroek, which was flooded during several weeks in January 1976. The original Sigma plan was contained 3 measures: a general heightening of the river embankments combined with the construction of 13 controlled flood areas and a storm surge barrier just downstream Antwerp. Here you can see an artist's impression of what this barrier would look like. But it was never built. It should have had 3 towers of 120 meters, which is about the same height of the Cathedral of Antwerp. In 2000, most of the strengthening and heightening of the embankments were finished. Also, 12 of the original controlled flood areas were constructed. The last one, the polders of Kruibeke, with a total surface of 600 hectares, was completed in 2015. The construction of the barrier was postponed indefinitely because of a cost-benefit analysis showed that a storm surge barrier could not be economically justified. One of the 13 original controlled flood areas is Tielrode Broek, with a surface area of almost 100 hectares in Temse, where the Durme flows into the Scheldt River. And here you can see how it works. We have a so-called ring dike surrounding the area. We have a lowered and reinforced existing river dike that is transformed into an overflow dike. And there is a discharge sluice in the overflow dike to let go the water back into the river after storm tide. Sorry. This is the same controlled flood area, Tielrode Broek, after it's filled with water after a storm tide. Another one, this is Bovenzande. How does it work? As I said, you have a ring dike, you have an overflow dike. This is a typical tidal curve of the River Scheldt in normal conditions, with the possible variations between spring tide in red and the dead tide in green. And when a storm occurs, the water flows over the overflow dike. And the water is collected between the overflow dike and the ring dike. This is again Bovenzande after a storm tide. And this is, oh, sorry. I have to go back. This is, if it works. Yes, this is footage of the overflow dike of Kruibeke. It has been filmed with a drone in January 2022 during one of our last storm surges. Unfortunately, the technology is not doing very well. This is our biggest flood area, Kruibeke, Basel, Ruppelmonde, as I said, with a surface of 600 hectares, and the overflow dike is about 6 or 7 kilometers long. The original Sigma plan, which was elaborated in 1977, needed updating because of new insights and developments. There's a new vision on water management in which we want to give more space to the river. Of course, there are the effects of climate change with the sea level rise, and we also have to implement certain nature conservation objectives like Natura 2000, Water Framework Directive, the long-term vision of the Scheldt estuary, and the Flemish nature preservation laws. So an update for the Sigma plan was necessary, and the decision was taken by the Flemish government in July 2005 to adapt the Sigma plan. Some figures with the updated Sigma plan. It exists of 645 kilometers of river embankments and quays, including the restoration and the renewal of the Scheldt quays in Antwerp. This is important to protect the large city of Antwerp from flooding caused by storm tides. In total, more than 40 space for water projects were defined, which allow to realize 2,500 hectares of controlled inundation areas and 5,100 hectares of nature development. The ambition is to complete the updated Sigma plan in 2030. That is, if the budget keeps on flowing like it should be, and that is sometimes a problem. Here you can see the phased implementation with the projects 2010, 2015, 2020, 25, and 30. And here you can see also which level we want to achieve in the different zones. The figures are given in meters TAW, that is the Belgian standard, about above the sea level. It's different from the sea level in Holland or in France, for instance, but it gives you an impression. In the Sigma plan, we try to work with nature-based solution. It's about sustainable management and the use of nature for tackling socio-environmental challenges like climate change, water pollution, disaster risk management, and so on. Other names are working or engineering or building with nature, and ecosystem services are also involved. Our philosophy is to work with nature, not to fight nature, and therefore we want to create more space for the river, restore and enhance the ecological processes, and involve the stakeholders. It is very important to have the support of a wide range of stakeholders in such a huge projects with a large spatial impact. Flanders is densely populated and each acre of land is used for living, farming, nature, recreation, and so on. So in the updated Sigma plan, we have a chain of new controlled flood areas along the Schelde and its tributaries. Here you can see some examples. The technique is a little bit slow. We also introduced some new concepts such as flood control areas with reduced tides. Here we combine safety with nature development. During the last 100 years, a lot of the low dynamic tidal nature, such as mudflats and marshes, have disappeared. And in the Sigma plan, we want to restore this type of nature. In this type of controlled flood areas, we mimic the tides, but in a reduced manner. We do this by installing an inlet and an outlet sluice. Every day, a little bit of water flows twice in and out of the area on the rhythm of ebb and flow. This results in the creation of tidal nature with floods and marshes. Mud flats and marshes. When a storm arrives, then of course the area can fulfill its function of storage of water like normal flood area. Here on the right, you can see the in and outlet construction. And we have dozens of those in working. Here, for instance, you see the controlled flood area called Zennegat. It is in normal conditions with water flowing in twice a day. Sorry. And this is the same area after a storm tide when it is used for water storage. This is another one. This is Bergenmeerse. In normal conditions, it's a natural space, as you can see, with marshes. And this is the same area after a flooding, after storm tide. A special project is the structural stabilization of 6 kilometers of Schelde quays in Antwerp. This is necessary because the quay walls were in bad conditions. They were built more than 100 years ago. A specific stabilization technique is applied in each of the 7 zones. After stabilization, we replace the existing water barrier with a higher and better looking alternative. In cooperation with the city of Antwerp, we give the case a profound makeover to strengthen the link between the river and the city. Here, for instance, this section is finished and it shows the integration of a new public space after raising and stabilizing the quay. Where possible, we create work with work. For example, in Vlassenbroek, along the River Scheldt, we constructed several dikes with dredged river sediments. There was an intense collaboration with the stakeholders during the preparation of the Sigma plan and during the realization of different projects of the Sigma plan. Stakeholder involvement has been achieved through a wide range of measures. In the next slides, you will get some impressions. Visitors from different countries come to visit the project of the Sigma plan. I guess that's because it's quite innovating. And in May 2018, the Flemish Waterways, the Agency for Nature Development and IMDC won the 3rd prize for the Piank Working with Nature Award for the project Kalkense Meersen, which is one of the flood areas. We are very proud with this recognition, of course, which shows how the goals of safety, nature development, and navigability can come together. The Sigma projects of Polders van Kruibeke and Kalkense Meersen are also selected by the United States Army Corps of Engineers as an example in their Atlas on Engineering with Nature. Maybe the name of Todd Bridges, the national lead for the Engineering with Nature initiative, rings a bell. So this is a little introduction on the Sigma plan. I don't know if you have any questions. I would say shoot.
Okay. Patrick, first of all, thank you very much for 2 nice presentations. I already see 3 hands raised and 4 hands raised, so it's going to be very, I think Demos was the first hand, then Vana, then Bart, then Amar, and then Miron.
I did not raise my hand, I just applauded for...
Oh, you applauded.
Me too.
You too. Okay, so that's quite easy. Then Vana.
I think Miron was first, so I want to
Miron first. Okay, go for Miron first. Miron?
Yeah, thanks. Very nice presentation, Patrick. Just a short question. When you let water into these areas, you also let sediment into these areas. Do you have to dredge a lot, or do you plan to use the sediments maybe as a clay refinery, or do you have other plans with that? Or?
No, well, in fact, the inlet sluice is very high. That means that the water that flows into the areas is not really loaded in sediments, as if the inlet sluice would be lower in the dike. We had a first area 15 years ago to try out how the sedimentation would evaluate, and actually it wasn't that bad. So we still have measurements going on to see how many centimeters increase there is, and it's not really that much. So we think that it will last several decades before the volume that we can take in for water storage. We don't think that the areas will be filled with mud very quickly.
Okay, thank you.
Okay. Vana?
Well, I had two questions. Since you talked about the sediment, I wanted to ask you about the projects where you have a controlled tidal area, which I understand that you reduce the tidal height. So is this related to the sediment supply? So is this the reason that you want the tidal levels to be controlled in those areas or not?
You mean in the well, actually we when we let water in on a daily basis, when there is no flood tide, we let only a little bit water in, because what we want to do is we want to mimic marshes, and we want to create natural spaces. And also this system has a very good influence on the water quality, but there's not really a goal about the sediments. I think I don't know if I got your question.
Now, what I assume is that since you control how much water gets in and out daily without letting the whole flood of the tidal wave come in, this also controls naturally also how much sediment you get.
That's right. And as I said, since the inlet construction is rather high, and the upper part of the water in the river does not contain a very large load, that means that there's not that much sediment coming into the controlled areas.
Okay, then can I go to my second question, or somebody? Okay, I was quite intrigued about the cost-benefit analysis that you mentioned about the storm surge barrier. So I was wondering when this took place, and if it was based only on pure economic criteria, or all this social support and social welfare criteria about ecological value and stuff like this were taken into account.
It's about it's already about 15 years or more ago, and I was not involved in this exercise. So all I can say is that I think it was mainly an economic exercise, in which the conclusion was that it is better to invest in the creation of flooding areas, and take also into account the costs of the little risks that remain when there should be a flooding. There will also be some damage if some little floodings occur on places where we don't want them. But since we have quite a lot of areas that can be flooded, where we want it to be flooded, we think that the damage would be rather small. And that was taken into account to decide whether the building of the barrier was economically suitable or not. And the decision was, or the conclusion was, that it wasn't. So it was way too expensive to build that barrier, and that's why they decided not to build it. But I'm not sure if at that time, speaking about 15-20 years ago, when the exercise was done, other goals were also taken into account. Maybe Patrick knows that, because I guess he is longer involved in the Sigma plan than myself. But I don't know.
Okay. I see ping pong game between Patrick and Patrick. Patrick.
Well, what I can remember now is there was a kind of return on investment analysis, and then the combination of flood control areas and let's say bringing the weak spots in the levee system up to the correct strength gave the fastest return on investment. So even with not too much climate change, within 30 years, we would have a positive result, and all the other solutions were not that easily earned back or quickly earned back. But the decision or the actual measures or the decided measures now, they will not keep us dry until 2100 and more. So maybe additional measures will be needed, but the one decided gave the quickest return on investment. On top of this economic analysis, there was a multi-criteria analysis on also the different options, and there, although I don't know exactly how they are weighed, but other criteria as ecological advantages were sort of taken into account.
Thank you.
Patrick with CK. May I ask you a question? We had last summer we had the flooding in Wallonia, Limburg, Netherlands, and in Germany with the flash flood thing. Do you think that event, at least in the Netherlands, it shocked us a little bit, let's put it mildly, that it also, I think in Flanders it's called the waterbom, would it change, let's say, how they look at the Sigma plan, or will they adjust the Sigma plan or extend it, or do you have any idea how that will operate?
Well, our minister and the Minister of Environment asked us to see what the event of July last year would be if we if it would be applied on the other regions of Flanders, because the Schelde area was not really involved last year. But I think that they did not really look to the Sigma plan, because the Sigma plan is really, the goal of the Sigma plan is to cope with floodings that are related to storm conditions coming from the sea. And the waterbom that we had last year, of course, is a pluvial situation. And I don't think that they really looked at the combination of both. We think that the volume that we can store in all our Sigma areas is quite high, is quite much, but I'm not sure what the result would be if there would be a water bomb coming on top of it. And again, I think that Patrick Peters is maybe better placed to, if he's still there. Maybe you have a better idea about this, Patrick.
On the combination of these enormous pluvial events and tidal events.
Yeah, and tidal events. So we also had the question ourselves: what would the situation be if the event of last year, the water bomb, would come together with a storm tide? Because then you have on the one side water coming from the sea in a big amount, and also the water from the rain, and the combination of both what does it mean? What conclusions do we have to take?
Yeah, I have no I can only speculate. Let's say until a couple of years ago, the answer was more from, let's say, the available statistics that they are not linked. And okay, we can have bad luck that they are at the same time, but there are no statistical informations that confirm that that the chances of having both at the same time is increasing or changing. Or but what I know from some experts in Belgium recently is that they do find signals that following climate change, these so-called compound events, which is combining different risk elements, and having them at the same time is increasing. So it is something we maybe have to tackle more in the future. But as for now, and even the new hydraulic boundary conditions we use to check on scenarios and to evaluate whether a certain flood control area is a good one, is not including this increasing trend of compound events. So for now, we are not. We can have a disaster scenario combining it, but we cannot put any statistics on it. So sometimes it is simulated, but in the historical statistical boundary conditions we use to come up with return periods, we don't combine them yet.
Okay, thank you very much, Patrick, for your very interesting presentations too. So thank you, very interesting. I think we're more or less at the end of the first partner meeting of 2023. There are a lot of opportunities